Hi there, and welcome to this lesson. Now, in this lesson, we're learning differential calculus, okay? And under differential calculus, we'll be learning about the derivative of a product. Okay, now, at this point, I'd remind you to set the video to play in 1080p HD. Very important that you do so you see everything clearly. And as the lesson progresses, if you have any issues at all, anything comes up as unclear, please feel free to get in touch. Okay, we would be more than happy to help. Okay, let's jump right into the lesson. So, differential calculus, the derivative of a product. Now, consider this function y equals x squared minus 3 multiplying 5x plus 1. Now, what we have here is a product. So our function here is a product of two functions. The first being x squared minus 3 and the second 5x plus 1. So if you have a function like this and you're asked to find the derivative of this function, how would you go ahead with doing that? Now let's find out. So I'm going to split this function into its two parts. Okay, we have two things multiplying themselves there. So we have the first one, I'm going to call that u, x squared minus 3, and the second being 5x plus 1. So we have v as 5x plus 1. So we have u and v. Now, basically, you'd agree with me that y equals uv, okay? U times v, because u is x squared minus 3 and v is 5x plus 1. Okay, so y is the product of u and v. So if you have a function like this, how do we find the y dx? And we have this formula. Okay, the y dx is u dv dx, okay, plus v du dx. Very simple, that's it. So what we do here is to find the derivative of a function that is a product of two functions. We take the first function, okay, u, and then we multiply that with the derivative of the second function v with respect to x. Okay, so keep u constant, differentiate v, all right, and then we add this to v, differentiate u. Okay, so we keep v constant and we differentiate u, and that is pretty much how you find the x when you're working a product. So if you have the y equals x squared minus 3, 5x plus 1, and you have the u is x squared minus 3, and you have the v is 5x plus 1, to find the y dx, the first thing you do is you're going to keep u constant. So we have x squared minus 3. I'm going to multiply that by the derivative of v. And so if we differentiate v, 5x plus 1, we have 5. Okay, so we have x squared minus 3 multiplying 5. X squared minus 3 dot 5. And we're going to add this to keep v constant. So we have 5x plus 1 multiplied by the derivative of u with respect to x. So we differentiate u is x squared minus 3. If we differentiate that, we have 2x. And that is it. From this point, we basically just simplify our answer, and would have that dy dx is 5x squared minus 15 plus 10x squared plus 2x. And we have a final answer as 15x squared plus 2x minus 15. And that is how you find the derivative of a product. Very simple, very straightforward. Now let's do an example. Example 1. And example 1 says if y equals 1 plus 5x multiplying 7x minus 2, find the y dx. Now, how do you go about doing this? First thing we want to do, we identify a formula. The y dx is keep u constant, differentiate v, plus keep v constant, differentiate u. Simple. Now, what is u? U is 1 plus 5x, okay, the first function there, and v is 7x minus 2. Okay, and if we put those into our formula, we have that dy dx is keep u constant, 1 plus 5x, multiplied by the derivative of v, we have 7x minus 2. If you differentiate that, you have 7, okay, plus keep v constant, 7x minus 2, differentiate u, and you have 5. When you differentiate 1 plus 5x, you have 5, and you simply expand that out and you end up with a final answer 70x minus 3. It's actually really easy. It's just a very simple formula. Keep u constant, differentiate v, add this to keep v constant, differentiate u. Simple. Now Let's do another example. Example 2. Now example 2 says if y equals 2x squared minus 9x plus 3 multiplying 8 minus 3x squared, find the y dx. Okay, our formula is keep u constant, differentiate v, keep v constant, differentiate u. Okay, and then we have that y equals 2x squared minus 9x plus 3 multiplying 8 minus 3x squared. Okay, and we have that u, in this case our first function is 2x squared minus 9x plus 3, and v is 8 minus 3x squared. And from this point, the y dx, we keep u constant and we differentiate v. When we differentiate v, we have minus 6x. Okay, and we add this to keep v constant and differentiate u. When you differentiate u, you have 4x minus 9. Okay, and from this point on, we just expand that out, and when we do that, we end up with a final answer minus 24x cubed plus 81x squared plus 14x minus 72. Very simple. Let's do another example. So example 3, and example 3 says if y equals the root of x multiplied by 3x plus 1 squared, find the y dx. Okay, so how do we go about doing this one? This one looks very interesting, but it's pretty much the same process. So we keep u constant, differentiate v, and we keep v constant and differentiate u. So y equals root of x multiplied by 3x plus 1 all squared. U is root of x and v is 3x plus 1 all squared. If you look closely, you'd realize that v is actually a function of a function. So we actually have a function of a function in a product. Very interesting. So how do we go about doing this? The y dx equals keep u constant and differentiate v. Now you'd be keeping u is root x, so you keep root x, multiplying the derivative of v, and you would find the derivative of v by function of a function. You find the derivative of a function of a function, and you would end up with 6, I think. Okay, so because you differentiate the inner function, you have 3 multiplied by differentiating the outer function, you'd have 3x plus 1. So in the end, you have 3x plus 1. Okay, and then you add this to keeping v constant and differentiating u. When you differentiate root x, you end up with 1 over 2 root x, and then you'll find, I think this is our final answer. You can expand further if you want to, but you can actually have this as your final answer. You have 6 root x multiplying 3x plus 1 plus 3x plus 1 squared over 2 root x. Very simple principle, which would bring us to the end of this lesson. And yeah, all you need to remember, keep u constant, differentiate v, keep v constant, differentiate u, and that is pretty much it. Bye for now.